Bizarre. All right. Welcome back, nerds. So we've had a few minutes to jump into this today, right, chat?
Yeah, sure.
Cool. Awesome. All right. So I like your guys' algebra, and I just really want to commend you. I agree wholeheartedly with everything that you've done algebraically. If you need a minute to get these in, I would encourage leave space. You can take pictures on your way out. You can get down anything that we've done on the board. You can take on your notes with you when you leave. But I want to jump in to this and see, like, are these really different answers? Kind of not. Have a unit circle in front of you. And I want to jump in each of these problems. We're just going to jump in somewhere slightly different. We all got to the same point where if I look at any groups on A, we're going to get down to the fact where sine x is equal to plus or minus root 3 over 2. And then it's at this point where groups decided, oh yeah, I'm just going to write this as arcsine, and we're done. Here's the deal that I'm going to make with you. We will inevitably use arcsine as an answer at some point. But what I want you to do right now with your unit circle, I want you to find, is there anywhere where sine on my unit circle is positive or negative root 3 over 2? And I want you to verify, like physically point to it on your page, make sure that you can see it. If you can't see it or you don't know what I'm asking, this is the right time to clean it up. Look around your unit circle, find me anywhere where sine is either positive or negative root 3 over 2. How many fingers do you need to use? 4 of them. Do we all agree there's 4 places where this happens? Now, I'm going to shift. I'm going to think about this on the circle, and it's going to be a really bad circle because I'm drawing it from here. But here's a unit circle, kind of. Where is root 3 over 2 going to happen? So up here at pi thirds, 2 pi thirds is up here, 4 pi thirds, and 5 pi thirds. Can everybody agree that those are the 4 spots on the unit circle where this happens? Okay, now here's the wonky part. This group loved their answer. Do you guys agree that if I start here at this, how far in radians do I have to go to get back to that spot? So, and it happens with 1 circle, it happens with 2 circles, it happens with 50 circles or a billion circles, doesn't matter. So I'm okay with these answers being x equals, well, let's start here. We could say pi thirds plus 2n pi. Before we move on, any confusion here? Now, this is going to be redundant, but I'm also going to have 2 pi thirds plus 2n pi. I'm also going to have 4 pi thirds plus 2n pi. And I'm going to have 5 pi thirds plus 2n pi. Okay. Anybody look at this go, yuck, I hate writing these answers. They're awful. Okay. Only about half of you are volunteering, but can we just all agree that, yeah, this is, if only there were a better way. If only there were a better way. Well, here's my question for you. Instead of writing all 4 of these plus 2n pi, can you write this, all of these points to guarantee to be hit, even if we don't write all 4 answers? So is there a simpler way that I could write less than 4 things to ensure that I get every single one? Okay, Dolan thinks he has it. I want you to check it out, talk with your neighbors like 30 to 45 seconds. What if I only wanted to write 2 answers plus something? Can we make it happen? I saw you nod, maybe yes.
So
what do you think?
Probably use n for the like n pi thirds.
Ooh, I like where that's at. I think you're on the right track. Okay, anybody think they have a solid way to explain this or think about it? So I don't know that I agree with the first 2, but this one, the first and the third, do they link up any meaningful way? They're half a circle. I don't need to be right in your space here. They're half a circle away from one another. Is that always going to be true? If I just go a pi, I'm going to hit that one, and then the next one I'll hit here, and I'm just going to keep hitting those ones. And it's going to happen forever, right? So maybe I can take those 2 answers, and we'll just put this or, because there's a bunch of ways we can write this. Maybe I could just start at pi thirds, x equals pi thirds, And instead of adding 2n pi every time, what allows me to hit this and this? How far do I need to rotate? Pi away, right away, right? But then if I go 3n pi, I get back to here, or 4 pi, 5 pi. Like, I just keep hitting it. Maybe we can simplify those down to just be this. Like, it's not required, but does that still hit them all? How do I put, I'll switch colors. How do I put this one and this one together? Talk with your neighbors, try to write it out. X equals, see if we can write it, even if it's in your margin, can you write it more concisely? Do you understand how we're getting this? So check it out. Were you able to find, when we did this, did you find the 4 spots here and here? So check this out. How much of a circle are these two away? Like, I don't want to draw on yours. Let me grab a different one. Let me just grab a blank one. I'll draw on it. You guys think you got it? Notice this relationship, and it's going to keep happening. So if we don't notice it right away, like, we're going to get more shots at it. Here's 5/3. And then how much of a circle have I had to go to get from here to here? Pi, right? So if I just add pi, do I still get both of those answers? If I add 2 pi, do I get the next answer again? Is it going to keep cycling? Anytime that we get these angles that are exactly half a circle away, instead of writing 2 answers with plus 2n pi, we can just use one of the answers with n pi. Now we're going to see other variations of that, and you are welcome. I'll leave this here. You're welcome to draw on that if you don't want to scribble up yours. Okay, anybody confident and proud of your answer for the second part? I don't know where well, this is a new problem. I have my stylus. Where did I put down my board? Basil. All right. How do I write this one, Red? I heard you say it like right away. 2 pi thirds plus n pi. 2 pi thirds plus n pi. And that guarantees that I hit this spot. And then notice my other solution is exactly where on the circle from it. So, I mean, there's a few ways you could explain it. It's pi away. Would you agree it's right across the circle? Like, that's what I think of. Like, it's exactly on the other side. It cuts the circle in half. Cool. Now, in the end, I really don't care whether you give me these 4 answers or if you give me these 2. But I am going to let you guys know that if you give me, I'm trying to point to their board. If you give me the arc sign of something that's on the unit circle, like clearly on the unit circle, one of the 3 or 4 nice values that we have, I need the actual answer. I will not give credit for the arc sign there. Cool. Awesome. On B, the factorization, you guys did really well. I'm going to jump in until we get to the very end. This thing factored as, it looks like 2 cosine of x minus 1, 2 cosine of x minus 1, and cosine of x minus 2. As you guys were factoring, were there any issues that we need to talk about on how we got to there? I see all the groups were able to factor it to this form, but is there anybody who maybe should have been asking your group questions about stuff that you're not quite sure how we got here? Okay, so here's my challenge for you guys again. It can be on scratch paper. It can be like, if you're doing this example in your notes, I think that's probably a good idea. Find me the most concise way to write these answers. I'm going to give you guys a minute. If you need to start, and not if you need to, I want you to start by writing all of them out like this. And then once you have them all, see if we can write it more concisely. I can. Cool. How did I get the pi? Weird. What did I do? What did I do? All right. How do I get pi thirds? Okay, so if you want me to show that thought on the board mathematically, I don't think I can write all those words that fast. Oh no. You know what? I have the other one written. You guys have it written. We're just looking at this one so I can clear some space. You know what? I'm just going to come up here. I don't know why I'm still walking around. Kind of like it though. All right. The question was, how did you get the pi thirds? Well, let's sort it out. Remember that math and magic you guys did at the start of class? Where if I have a number that I claim is equal to 0, then you know that the other number is, I don't remember how I worded it. You guys know what I'm talking about?
Yes.
You don't know my number, but 5 times that number is 0. What's my number? 0. So when we solve these, and a lot of the time, maybe more than I need to, I just put this in my head as like scratch work that I think out. And I think that you guys can probably solve these equations, at least from the beginning, nicely, to write them out. Help me solve for x. I want to isolate anything that has an x in it right now. I need to do 2 steps. Add 1 and divide by 2. Lay, are you okay with how we got here? Okay, do you have a unit circle in front of you? Do you really? I want you to look at that unit circle, Lay, and I want you to find me any places on that unit circle where x or cosine is 1/2. Okay, there's my first one. Here's how we got that. Where else? Okay, now what is this part telling me I can do? I already wrote it underneath, but any number of full circles will always take me back to the same spot every time. Okay, now the question that we started with, there's that one. When's this equal to 0? At 2? Show me on the unit circle where cosine is 2. What's the biggest or smallest cosine ever gets? 1 and -1, right? We have a restricted, like our range only goes from -1 to 1. Is it ever going to be 2? So somebody said the word extraneous, extraneous if you need to. Extra answer. It's garbage. Cosine of x equals 2? Never. Can't do it. Get out of here. You're garbage. Okay. Now, the question was, write this as concisely as possible. Can we write this one any more concisely? I don't think so. Like, we're not able to do it. For the last problem, do we need to work through the last one together? Okay. Can somebody give me the factors? And I don't even care where we started. You guys can, again, take pictures, write down the problems in your notes. Yes, ma'am.
So there's no answer at all for
These are our answers. I'm sorry. Yep. Yep, these ones cannot happen. These ones do happen infinitely many times. But these aren't half circles away from each other, are they? So we're going to do one more. On C, let me just check to see how people got here. Love it. I'm going to jump in right here. Do we need to discuss the factoring here? I have one question that I'm going to call on somebody random. I'm going to cover that one up because this group did a really good job of showing their work, whoever this group was. Kudos. How did they replace a secant squared with tangents? Pythagorean identity. Secant squared is 1 plus tan squared. Okay, so I'm just going to jump in, ... We had tangent x is equal to plus or minus 1. Now, it takes practice. Help me write the 4 solutions first. X equals pi fourths plus what? Do you agree that any full circle? And this is going to get tedious, and I'm aware of it, but I'm hopeful that we can all agree that if there's an easier way to write all these, we should probably take it. It's going to happen at 3 pi fourths. And you know what? I'm just going to do this. Plus 2n pi. I need the plus, I suppose. You know, I don't know if it's efficient anymore when I have to start doing stuff. Anyway, it will be. It happens at x equals 5 pi fourths plus any full circle. I don't know. And it happens at 7 pi fourths. Okay, here's my challenge for you guys. I want you to do 2 things with these answers. The first one, I want you to write this as, like right now, do you agree we have 4 solutions written? Like, and that's a weird statement because really we have infinity solutions written, but there's 4 statements. I want you to take this and I want you to make it 2 statements. And everybody, I want you to do this on your page. If you need to leave space so you can practice the factoring, I would encourage you to do so. But once you do 2 statements, I want you to just go absolutely yak on this, and I want you to write it as a single statement. These are all variations of the same answers, and it's important that we can recognize that there's a lot of different ways to express them. This one will always work, but maybe you don't always want to write 4 different solutions. Cool. Talk it out with your groups. We'll come back together. You know what? Stand up and talk to somebody that you don't normally talk to. We're going to mingle. Cool. So stand. Should we do circle in a circle? We can do that if you guys really want to. Okay, so stand and mingle. Talk with somebody that you don't normally. See if you and whoever you're choosing now can write this as two statements. Cool. So I have the unit circle in front of me, and whether you physically mark it or not is up to you. But I'm going to mark pi fourths, and I'm just going to draw the angles. Here's pi fourths, and I'm going to make it more like obnoxious and clear. That's too much. Everybody agree that's pi fourths? And then that's 3 pi fourths. And this is 5 pi fourths, and this is 7 pi fourths. If I wanted to write this as two answers, if I start here, how much do I have to rotate to only get this and one more over and over? If I go pi, I wind up here. And if I go another pi, I wind up back here. Do we all agree? So if I want to condense that down to two answers, did this help, first of all? Can we all see that this and this are exactly half a circle away from one another? Like that's what looking at the unit circle helps for. So if I want to write it instead, well, let's just condense this down. We'll do two statements here. I have x equals pi fourths. And then if I go half a circle, I wind up at 5 pi fourths, right? So that's like this one and this one combined together. And how do I write any number of half circles? N pi. I have taken care of those two. To get these two together, I'm going to start at 3 pi fourths. And we'll do the same thing here in just a second. So here I am, 3 pi fourths. Here and here are the other two answers. How far apart are they on the unit circle? Pi. Would any number of half circles get me through there? N pi. Cool. We can write it as 2. Now, this last one, the one singular statement. Anybody confident that you can do this one? So let's check. If I want to go from here to here, how much do I have to rotate? It's a quarter of a circle, 90 to 90, right? Or 45 to 45, it's 90 degrees. That's pi half rotation. What if I rotate another 90 degrees? And I'll even make it look like 90-degree angles instead. Is that another 90 degrees and I got this answer? If I go another 90 degree, oh my goodness. It just keeps happening. Every time I only have to go, and I think Christina might know this, how far do I have to rotate every time? Pi halves. Can we all agree that just by jumping pi halves over and over, we get it? Like I keep landing back on those points. So what's the easiest spot to start at? Pi fourths would be the natural choice, but realistically you could start at any of them. If I start at pi fourths, I just need to do any number of quarter circles because I need 90 degrees. That's pi halves, and we'll call that n pi halves. If you were writing these on a test, which one do you want to write?
1.
So I assume that this is what you mean by 1? Okay, because that was poorly worded, because that's option 1 was like,
One statement.
I prefer this. If you don't, is that okay? For sure. If you want to write 2 statements, is that cool with me? Indeed. If you want to write 4 statements, is it cool with me? If I want to keep my answer as x equals the arctangent of plus or minus 1, is that cool with me? No. Now, if it was like 3/5, I don't know what the arctangent of 3/5 is. That's an okay answer, and we'll get to those. Okay. Seem doable?
Yeah.
All right. So tonight, you get to practice some of this. So, I have so much stuff to do at lunchtime. Yeah. You know what? I'm going to write it and then I'll put it on Google Classroom. You guys, I have a clipboard right here. Cool. This is homework 5.3.1. Anybody looked at how many sections there were in chapter 5? There's only 5? Interesting. I want you guys to do problems 1 through 3. 5, 12, 16, 17 through 29 odd, and 36. Cool. All right. Do it to it. You guys got 5 minutes. We can get started on it.